In the previous videos, we mentioned about the detailings in the structural plan which are produced by the engineers. You know that every single element in RC structures needs to be properly illustrated, carrying sufficient information for the contractors to be able to fabricate the members in the construction site. The detailings of each members are to be read in concurrent with the structural key plan which has been established at the early stage of your assignment. You will use the structural key plan for your analysis and design, and then the design outcomes are to be illustrated in the detailings of each members. When you construct the detailings of each members, you need to make sure the information given in the detailing needs to be in line with what is given in the structural key plans, particularly the names of the members, the conditions of the members, the dimensions, the respective grid line, and etc. The detailing needs to be detailed enough with proper illustrations as well as proper leveling, which should be drawn in the neat way, carrying as many informations as it could in a very concise manner so that it is friendly to the contractor for them to proceed their work in the construction site. Not only you need to consider the technical aspects, which the technical aspects are quite standard. You can acquire those from the lectures as well as the references for the reinforced concrete design. You will need to also consider the applications on site, knowing how the works are being done, how the projects are being supervised and monitored, and how can you help in increasing the productivity and efficiency of the works. So far, we have covered quite a number of types of elements. These include the beams, the slab, the columns, the foundations, the staircase. We also demonstrated some samples of the detailings, which can be an idea for you to produce the detailings of your own. Now we're going to proceed our discussions with two more items which is equally important. It may not as important as it seems, which can seem to be quite minor. However, knowing how it is being done is very important, as it will directly influence the aesthetic of the structures, making sure all the architectural features as well as the gutter are stably attached to your main structural element. Although the looks adding onto this kind of elements is not high, most likely they're going to carry their own self-weight or maybe minor imposed load, which is not significant. However, you must take this into considerations so that during fabrications of each adjacent structural element, the gutter and the architectural features can be fabricated together as a part of the structural element. Otherwise, in order to ensure those elements are to be attached to the structural element after you have constructed the respective members, this will lead to complications in terms of the work. There will be a lot of challenges to ensure those are to be stabilized and attached to the entire structures. All this needs to be clearly indicated to the contractors. What we are talking about, it will be the gutter and the architectural features. These are the additional things. One is for the functionality of the structure, especially the gutters is used to collect rainwater from the roof and quickly divert the water through the rainwater downpipe and subsequently to the perimeter drain to be discharged out of the building compound. As for the architectural features, this will include the facade of the building as well as the appearance of the buildings. This is another important criteria, especially to the concern of the architect as well as the client. The aesthetic view would directly influence whether the building structures is marketable and of demand by the local market. Now, how do you know what kind of gutter in terms of the shapes as well as the architectural features? Normally, we will get it from the floor plan of the architectural drawing, which is to be observed in concurrent with different views of the structures. And also, you will need to observe the cross sections of the building in order to acquire the exact dimensions. If those are concrete elements, that means they need to be properly attached to the structures. Then you need to embed reinforcement bar in order to ensure they are in the intended shapes and dimensions. Let us see some examples. First, we can observe from the architecture drawing, which initially we mentioned that to put the plan as well as the view of the building side by side for direct comparisons. For a typical building, depending numbers of the plan, you will have the equal numbers of this comparison throughout the building. For example, this. You're going to observe the floor plan floor by floor. You know that there are walls, and normally at the perimeters of the walls there are some extra things there, which you may not be fully aware of this if you refer only to the floor plan. It will only be noticeable when you see the side view. You know that this part of the building is actually this part, and also you know this part of the building is actually this. You also see something like this here, which is this, or you see something like this coming out from the wall. That means it will be this thing here, and you need to check if the thing is clashing into the windows, which in this case the window is on top of the thing. Now the problem is, how do you keep this attached to the wall? Most likely there will be an extension from the ground floor beam that made a short wall here, so that this thing can be attached to that short wall. And then it will be dependent on the cantilever length here to decide whether you want to have the entire pieces here to be RC, or you consider that as a part of the brick wall. If you make the entire piece here, the short wall plus this thing here to be RC, of course it will be stronger. Just that when you cast the beam, make sure you leave the tower bar outside for the following casting of the walls. And if the loading here are relatively low, which is achievable by having an extension of the brick wall, this probably will do. This will have to based on your experience. If you are not sure, maybe you just go for the RC element, as long as the architecture thing can be strongly attached there. Next, you also observe something like this. As indicated from the floor plan here, there will be a continuous wall going up from the ground floor until to a certain height at the roof level. There is a horizontal flat slab, and then you have another continuous wall. I believe this part you cannot do it with the brick wall. Most likely this is going to be an RC wall, where you're going to have reinforcement bar penetrating through different floors of the building until you reach to this level, and you have a slab also reinforced with concrete, so that this entire piece of architecture features are fixed to the structures. This design is quite nice. it looks attractive to the clients, and it is the responsibility of the engineers to ensure this is stably constructed. And then if you look at the first floor architectural floor plan, you see the walls and the building bodies. Along the perimeters of the wall, you see something coming out from the walls. This is most likely is going to be the architecture fixtures as well. You will need to observe from the side view of the structures in order for you to know that this part, it is actually this part, and this part, it will be something like this. And if you look at the side here, which we zoom it a bit, and you see that there are 3 fins running in concurrent. You're going to check the positions of the first floor level, which if you draw a straight line here, you know that this is to the level of the first floor. That means this extended concrete part is on top of the concrete beam, and this concrete fin here, it is at a certain height from the top of the concrete beam. You have to find a mechanism to have this supported. And remember, you have another fin here. Most likely you're going to have your concrete beam to the soffit of the fin here, and provide reinforcement bar so that the fin here can be attached together to the perimeter beam. Same goes to this design. Most likely the soffit of the beam will reach up to this level. Also, if you look at this, which is meant for the roof here, by looking at the level of the first floor, you know that this one is gutter, and it is slightly higher than the first floor level. Therefore, when you construct the gutter, provide detailing, make sure you cater for this additional height as compared to the first floor level. We shall look further into this gutter here. As from the first floor level, it should look something like this. That means there is a thickness of the gutter, and this is where the gutter is going to collect the water due to the roof at the first floor level. Be careful with the aesthetic column. Make sure you have those considered in your detailings and design. Same goes to the columns here, as well as the gutters here. And for the roof level, now the entire perimeter of the buildings are with the gutter. You can observe the gutter here to check their locations. Is it in line with your plan? And if you wish to know how does the gutter looks like, you can look at the cut sections. Let's say now we are looking for the cut section here. This will be the dimensions of the gutter. It is clearly indicate that this is the attic floor level, and your gutter should look something like this. This will be the beam, and there will be attachment to the beam. You will need to provide reinforcement bar as appropriate in order to ensure the shapes of this is maintained. There will be shelling, which normally the shelling is placed in the mode of rectangular shapes, something like this. And nearly every corners of the shelling, there should be a longitudinal reinforcement bar, as you may have difficulty in terms of the design of the member, especially how do you analyze the load. You can simply do some estimations or you will need to provide the longitudinal reinforcement bar, a minimum size of Y12 mm, and also beware of the secondary reinforcement bar, as you might have a concern of failure here due to the weight of the gutter. Therefore, make sure you provide sufficient reinforcement bar at 2 layers here in order to resist the members to fall down. Because you are dealing with this gutter, you want to prevent the leakage of the water. Therefore, you need to put reinforcement bar more closely spaced. And because this one will behave like cantilever, make sure there are top reinforcement bar at the slab of the gutter. This is another shape of the gutter. Just now we mentioned there is an extended height from the floor level, which if you look at the first floor level here, this will be the dimensions proposed by the architect. Since that the dimensions has already been proposed, if possible, you will need to adopt the dimensions as given, at least in terms of the view from the outside. Let's say now you find these two things, probably with the consent of the architect, you may increase it slightly. Regarding the reinforcement, it is the typical reinforcement that you provide for the drainage. And remember, for the double layer reinforcement bar, this is the side of the wall that we mentioned just now. This is most likely is going to be your beam, and at the soffit level you have an extended fin here, and at a certain height from your beam you have another fin here. Most likely you're going to design this beam in these shapes. Now your beam element, it will be here. You need to provide shielding in the rectangular conditions, and you have to provide the reinforcement bar both sides as a wall members here. At every corners of the shielding, there will be longitudinal reinforcement bar. And for the 2 layer of reinforcement here, it needs to be properly embedded inside the beam with a minimum anchorage length. Same goes to this fin. Most likely it's going to attach together with the beam here, and you have a wall which is reinforced, and there are reinforcement bar continuous to ensure this part is properly reinforced. And you know that this one, it will behave as a cantilever. That means you need to provide top reinforcement bar on top here. This is another one. The shape may be quite awkward. As already given by the architect, you have to find your way to reinforce it. You cannot simply increase the depth of the dimensions, as this may clash into the windows. The window frame and the door frame is something cannot compromise. You have to be careful with that. Same go to this section. Now you have a white beam here, and you have 2 additional fins here, and you have a fin which is at the offset distance above the top level of the beam. You have to find a way to have this in one piece along the beam span. These are the things that you have to take into considerations regarding the architecture features. As for the reinforcement bar, it can be something like this, especially for this layer of the reinforcement bar. It needs to be continuous. In fact, for this one, the better design, it will be this going to the end of the member and go up, while at the same time you have a member here going up on this side. You swap the positions, but you have to provide additional reinforcement bar in order to ensure the corners here. This design is actually simplified, as it is foreseen that this is just a gutter with the drainage attached, which it is not quite concerned about the weight. And sometimes you have something like this, which you have an extended fin here out of the beam. Make sure you provide reinforcement in order to ensure the corners are properly done. The best way for it is to have every twist in terms of the corners will have an longitudinal reinforcement bar. And you know that this one is meant for the architectural purpose. The loading acting on this part may not be high. You can actually reduce the amount of reinforcement bar. A similar design here, where you have a fin extended from the slab. Sometimes you have an awkward design. You need to be careful and clearly indicate the reinforcement bar inside the member. I don't have the samples of the reinforcement bar for this kind of awkward shape. All this you have to come up with your own, which you require some sense of the arrangement of the reinforcement bar in order to ensure the structures is stable. The bottom line here is, when you design for the beam here, you will consider a rectangular beam for the design. You might need to do some minor check in terms of the torsional loops applied onto it. That means under torsion, your shear links will play a significant role. You might need to have these members to have shear links to be more closely spaced, or probably increase the grade of the shear link that you use. For example, initially you use the mild steel, now you convert it into the high yield steel bar as your shear link, and then ensure that there are proper anchorage within the beam so that the entire members act as a monolithic section. And then whenever you present the detailings of the beams, which your detailing may seem something like this, and there is a need for you to show the cut sections, and this cross section of the beam will need to be presented in these shapes as a replacement to this T-shaped cross section. Clearly indicate every single dimensions as per the architectural drawing, as well as indicate the reinforcement bar inside the members. Let's say now if you are producing the detailings for this beam, you should have a member something like this, and then the cross sections with the reinforcement bar, it should be in accordance to the shapes as given in the cross sections of the structures by the architect. Now that we have briefly covered what are the considerations and how you should do with the gutters and the architecture features, I hope this can help you and give you some directions in producing the detailings of your structures. I would say that most of the students are not aware of this part. They overlook this, and this is also another important part demonstrating the level of understandings of the students on the architectural drawing as well as on the actual structures.